this video is how to plot linear inequalities graphically. So first, let's have a recap of inequalities. So you can see the inequality signs on the screen, and we need to remember those. So if we're looking to solve linear inequalities, then we need to treat it as an equal sign unless we're dividing by a negative number. So when dividing or multiplying by a negative number in an inequality, we need to flip the inequality sign first. So if I look at this example, I'm going to solve it first exactly as I would as if it was an equal sign. So first thing I'll do is expand my brackets. Then get x on one side and everything else on the other side. Now I need to divide by -2. Because I'm dividing by a negative number, that means I flip my sign. So I flip my sign, and I have my final answer. We can also represent inequalities on a number line, where the direction of the line or arrow indicates whether it's greater or less than a given number, and the circle is solid if it's greater than, less than, or equal to, and hollow if it's a strict inequality. So let's look at these examples. So if I have x greater than 8, I draw my number line, positive getting greater that way, and I know I've got 8 on the line. I've got a strict inequality, so I'm going to have a hollow circle, and it's greater than 8, so my arrow is going to go that way. Similarly, I've got x is less than or equal to -8, so I know that I'm getting greater that way. I've got -8 as my point. I've got less than or equal to, so I'm going to have a solid circle, and my arrow is going that way. So we can represent inequalities on a graph, but first we need to recap straight line graphs. So we know the equation of a straight line is y equals mx plus c, where m is the gradient and c is the y-intercept. M being the gradient is the change in y over the change in x, or rise over run. So what we do is we take the difference in the y values of our coordinate and divide it by the difference in the x values of our coordinate. C, the y-intercept, is just the value of y when x equals 0, so where the line crosses our y-axis. So if we're sketching inequalities on a graph, we're going to follow this method. So the first thing we're going to do is we're going to convert each inequality to an equation. So replace the inequality sign with an equal sign. Then we're going to draw the graph of each equation, making use of the gradient and the y-intercept given in the inequality. If the inequality is a greater than or equal to, or less than or equal to, we're going to draw a solid line. Otherwise, we'll draw a dotted line. Then we need to work out which region should be shaded. We need to put a point from the region into our inequality to see if it satisfies the equation. We also need to remember to check if the question asks us to shade the region that is or isn't satisfied by the inequality. So the first thing I'm going to do is I'm going to change all my inequalities to equations by changing the inequalities to equal signs. Now I'm going to want to sketch these, so I'm going to need them in the form y equals mx plus c. That's fine for my second and third equation, but I need to rearrange this equation. Now I'm going to draw my axes. I'm going to make sure I label them, and I label the origin. Now I'm going to plot my points, my lines. So the first one I'm going to plot is this one. So I know that the y-intercept is 5, so 1, 2, 3, 4, 5. So we're going to cross there. And I also know I've got a negative gradient of 1. So what does that mean? So I can put in another value so I can draw my line easily. So the value I'm going to put in is y equals 0. When y equals 0, 5 minus x is equal to 0. So 5 is equal to x. So I can plot that point here too. So I'll go along the x-axis, 1, 2, 3, 4, 5. So I know it also goes through that point. Now that also makes intuitive sense to me. I've got a negative gradient and it's going the right direction. So I'm going to get my ruler and I'm going to draw a nice straight line through that. I check my original equation, here I've got a less than or equal to, so I can draw a solid line. Now I'm going to go for my second equation, y equals x plus 2. So I know I've got a y-intercept of 2, so 1, 2. And I'm going to do the same thing. So when y equals 0, x plus 2 equals 0. So x equals minus 2. So I can plot that point here, get my ruler, and I'm just going to line that up nicely and draw that on. Again, if I look back to my equation, I've got a less than or equal to, so I know it's going to be a solid line. Now I go to my final one, so I've got y is equal to 1, so that is going to be all along here as a horizontal line. And look at this, I've got a strict inequality, so I know I'm going to have a dotted line in this case. So I'm just going to go dot, 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 dashed. Okay, so I'm nearly there. Now what I need to do is I need to work out which region satisfies all these inequalities. So I can see I've got this nice triangle in the middle here. So I'm going to pick one point from there. So let's pick a point from there. So I'm going to pick this point here. So that point is 1, 2. So I need to check that satisfies each of my inequalities. So if I put it in x plus y needs to be less than or equal to 5. X plus y is 1 plus 2, which is 3. 3 is less than or equal to 5, so I've satisfied that inequality. Let me check my next one. So I've got y is less than or equal to x plus 2. Y is 2. X plus 2 is 1 plus 2. So 2 is less than or equal to 3, which is true. And then my final one, y is greater than 1, 2 is greater than 1, so this is also satisfied. So that means that I know that my shaded region is this triangle in here. I hope you found this video useful, and let me know if you have any questions.